So this experiment is called chemical reefs, and for this experiment you're going to need these materials. We're going to use sodium carbonate, which is a little different from sodium bicarbonate, which is a material that's also called baking soda. This one is also called soda ash, so you see that same part of the name. And the formula for that is Na2CO3, so you'll find it in this little container, and it's powder. The other material that you'll need is copper sulfate. This one's in solution. And you can see it's a blue liquid. And then finally we'll need some distilled water. So we'll use this H2O and a tiny culture dish. You're going to start by filling the bottom of the culture dish with distilled water. So just enough water to cover the bottom, or a couple of milliliters. Then we're going to take our Q-tip and we're going to dip it in the water, and then we're going to dip it in the sodium carbonate, and we're going to put some of those crystals on this side of the petri dish or culture dish. You can see them there. I have this white card here as a background so that you can see the reaction better. Finally, I'm going to add a few drops of copper sulfate to the other side of the culture dish, and then we're just going to wait and see what happens. Think about what the liquid water particles are doing in the dish. Are they moving? Are they staying completely still? Try to notice what's happening to the blue liquid, and maybe you can even notice what's happening to the white powder. I think we can already see a little bit of a result here, so I'm going to zoom in, but then I'm going to allow the recording to continue. So you should see that a line has formed down the center of the dish where those two chemicals meet. And at that line, you see a darker color has appeared. Could also be called a precipitate, which is when a solid appears inside of a liquid as a result of a chemical reaction. And they call it a chemical reef because a reef is like a sort of a sharp edge in the ocean. So if you think of that as kind of a sharp edge.